Hello, everybody, and welcome to Campus 101 Exam Curriculum Series. Today, my name is Dr. Peter. Today, we're going to be looking at what I call basic chemistry. And I call it basic chemistry because even though some of us are advanced students, not all of us are on the same, not all fingers are equal. So some of us actually still need some reminder of the basic things in chemistry. So where else should we start if not the definition of the most basic thing in chemistry, which is an atom? Now, for my biology students in the house, I remember, if I tell you, remind me, what is the definition of a cell? Exactly. A cell is the smallest indivisible unit of life, right? Now, that's the same way we call an atom. Traditionally, classically, we define an atom as what? The smallest indivisible particle of an element. What this means is that an atom is the smallest unit of identity that matter can have. Now, there are subatomic particles. I'm not saying an atom is the smallest unit of matter. No, I'm saying the smallest unit of an element is the smallest unit of an element that can maintain its own identity. Now, since you're a chemistry student, we'll take it to the next level so that you can get this more. Now, so the question now is, so if the atom is the smallest unit of an element, what is an element? Now, an element, we know that matter is anything that has space, that has mass. Matter has mass and can occupy space, right? That's how we define matter. Now, but matter is composed of different particular elements. Some are solid, some are liquid, some are gases. Now, elements are the identity that matter takes in all its forms. Elements are the identity that matter takes, and an atom is the smallest unit of that identity that matter can take. This thing is not so confusing and it's very basic, and I hope you really understand it. But that is how we can go about it, all right? So now, in chemistry, before we talk about compounds, let's talk about mixtures. In chemistry, we talk about two types of changes. We have permanent change and temporal change. Alright, temporal change. When we say something is permanent, what do we mean? We mean it's irreversible. And when we say something is permanent, when we say something is permanent, we say it's irreversible. But when it's temporal, it means it can change. You understand? Now, all the things I've written on this paper, there's no way to clean it. There's no abracadabra I can do to clean it. It means a permanent change. You understand? But when I say something is a temporal change, it means I can reverse it. Now, I've closed this, but I can open it back. So it tells you what is reversible, is temporal. Now, when I mix, for example, let's say I have I have stones and sand, and I mix it all together into a beaker here, and I have stone, I have sand, I have water, all in this my beaker. Right? This is not a permanent thing. It's not a permanent thing because I can filter the water away. I can select the stones from the sand. It might take a long time. If I can even be a punishment, but at the end of the day, I can resolve it into its components. All right. This means that this is not a permanent change. This is a mixture. A mixture. You understand? This is what we call a mixture. A compound, on the other hand, is when elements react chemically. And when I mean they react chemically, there's exchange of electrons and protons and neutrons. And then there's exchange of electrons only. Exchange of electrons only. They react chemically and they form new products. Let me tell you a very simple example of a chemical change. For example, if I burn a piece of paper, understand? I have a piece of paper here and I light it on fire. That is an example of a chemical change. Now, to demonstrate this for you physically so that you know what I'm saying. Now, this is an example of a chemical change. This is a piece of matches and it's burning. Now, as you can see it burning, can you see? The piece of matches was as new as this. But now, look at what it has become. This is an example of a permanent change. There's nothing we can do about it. This is an example of a classical chemical reaction. I just want you to understand this. That's why I'm using every means possible to teach you. All right. So when I burn a piece of matches like that, what happens is that piece of matches has chemically reacted with the oxygen. Exactly. The oxygen in air. and as it reacted with the oxygen in the air, is now burnt. The wood, the carbon in that wood is now burnt to become coal. Wow. And you see how chemistry plays around every day at home. But sometimes we say we hate chemistry just because we don't understand the basics. So now we talk about compound. You understand? Now that's a reaction between what? Carbon in the wood plus oxygen in the air to give us what? Carbon dioxide, which is part of that smoke. That's that smoke that came out of the matches. You understand? That's a chemical reaction, giving a gas, leaving behind coal, carbon, solid in the wood. Can you see that? Easy. Now, I wanted to tell you about more type of mixtures. Now, we're going to be fast because this is supposed to be quite easy. Now, let me tell you about mixtures. Now, the thing about mixtures is a mixture can either be a mixture between solids, liquids, or gases. Right? Or a combination of any of them. Either I mix a solid with the gas or a mix a liquid. It can be any way. Understand? So that's what a mixture is. Now, before we go further and talk about mixtures, I want to tell you two other definitions. This is basic chemistry again. What is a solute? This one will come out in the exam. What is a solvent? And what is a solution? What is a solute? What is a solvent? And what is a solution? Now, a solute is a solid piece of matter, like for example table salt, sodium chloride. Solvent is a liquid such as water, such as petrol, such as, you understand, those are. And a solution is when I mix, right? It's a mixture of a solid and a solvent. Now, a very important thing that you are going to need to know is what is the universal solvent in chemistry? Exactly, water. Water is the universal solvent. So if I dissolve anything in water, it becomes what? A solution of that thing. For example, so I have salt, a spoon of salt, and I have water, in this plate here, and I mix salt inside the water. By mixing salt inside the water, I now have a solution of what? A solution of sodium chloride. Understand? So that is. Now, the last thing I'm going to tell us before we close this chapter is, even though we said an atom is the smallest unit, indivisible particle of an element, when we said that, I need you to realize that atoms are not just alone. If you break down, if you magnify an atom, you see that an atom has within its center a nucleus, and the nucleus is positively charged. If you have not watched our video on radioactivity, maybe you should watch it so that you can get more details into the structure of an atom. And then it has orbiting around that positively charged nucleus. Again, my biology students will be seeing nucleus like a nucleus of a cell, which is funny, right? But orbiting around that centrally positively charged nucleus are electrons. And these electrons that are exchanged in chemical reactions. You understand? So once again, let's take it from the top. We looked at basic chemistry. We said atoms are the smallest indivisible particle of an element that can participate in a chemical reaction. We also looked at element, and we said these are the identifiable units of matter. We said matter is anything that has space, has mass, and can occupy space, and then it's made up of different elements. We also said compounds. We talked about compounds, and then when we talked about compounds, we said when elements react chemically, they form compounds. We said mixtures are temporal changes, and we can mix solids, liquid, and gases. And we said solids or salts are usually called solutes in chemistry. Solvents are usually liquid, example water, which is a universal solvent. And we said solution is when we mix a solute and a solvent physically, and this can be and this forms the basics of our lecture in basic chemistry. So I look forward to seeing you in the other videos. We'll be looking at other topics in chemistry. Thank you. Now, in order to remember the first 20 elements in chemistry, we have come up with a song or a statement that can help you remember. Don't forget, we're talking about the first 20 elements and how you can remember them conveniently. Now, there's this friend I had who had a big head, but who could not offer full 9 subjects. So that's the song I just used to form it. He said, So that my friend now, he has large brain, but cannot offer full line subjects. Now, many art students put some charges against police cases. I don't know why art students do that, but it's true. Now, so what were we trying to do here? We're trying to find a way for us to remember the first 20 elements. The first one is helium. Don't forget H for helium, H for hydrogen. The first one is hydrogen. So and the second one is what? Helium. Has, you understand? The third one is what? Lithium. Large. You understand? So with this, we can actually get all the first 20. The fourth one is, don't forget, is boron. And the fifth one is what? Beryllium. Now, so we already know that he has large brain. That's helium, hydrogen, helium, lithium, boron. The next one is carbon. And after carbon immediately comes what? Nitrogen. And after nitrogen comes what? Oxygen. And after oxygen, of course, fluorine. And immediately after oxygen in the periodic table, the next element comes is what? Is fluorine. After that is neon. You understand? So now he has large brain but cannot offer full 9 subjects. Becomes helium, hydrogen, helium, lithium, boron, beryllium, carbon, nitrogen, oxygen, fluorine, and neon. Now, subjects: sodium, many, magnesium, art, aluminium, student, silicon, put, phosphorus. And we have in the first 15. So students, many art students, subjects, many art students become sodium, magnesium, aluminium, silicon, and phosphorus. And the last 5 elements are, when we get here, the next one is sulfur. The next one is what? After sulfur, I'm waiting for you to guess. Yeah, you're almost there. Chlorine. After chlorine is what? I'm waiting for you. Make an attempt. Argon. After argon, it is exactly potassium. And after potassium is calcium. And here we already have the first 20 elements. All right, so let's numbering them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here 11, 12, 13, 14, 15, 16, 17, 18, 19, and the first 20 elements. Don't forget them because they're important for you to do all the basic reactions you're going to be doing in chemistry.